This last video in this section, we're going to solve these trig equations that contain both sine and cosine. We're going to make a tangent show up, and then we're going to use arctangent to solve them. We're only going to solve them on the interval of 0 to 2 pi. So if cosine of theta minus sine theta is equal to 0, then we want cosine theta equals sine theta. And I want 1 equals tan theta. It's only legal to do this to make a tangent because we have not changed the domain at all when we do this. So only divide sine by cosine to make a tangent, or cosine by sine to make a cotangent. Never, ever, ever do this to try and eliminate a factor and get rid of something. Don't do that. So my sine and cosine are both there, hidden inside of the tangent, so I haven't changed anything. So I want theta is equal to arctangent of 1, and I want my answers that are in the on the first revolution. So that's going to be pi over 4 and 5 pi over 4. Quadrants 1 and 3. Cosine theta equals sine theta, really the same problem. 1 equals tan theta. So same answer, pi over 4, 5 pi over 4. Root 3 sine theta minus cosine theta equals a -1. So we're going to say here that sine theta equals cosine theta plus 1, sorry, minus 1. And so I'm going to square both sides here. I don't usually like to do this, but we'll check our answers. Then we're going to convert this into 1 minus cosine squared. So this is 3 minus 3 cosine squared theta equals cosine squared theta minus 2 cosine theta plus 1. 0 equals 4 cosine squared theta minus 2 cosine theta minus 2. Divide everything by 2. 2 cosine squared theta minus cosine theta minus 1. Let's factor. Is going to be 2 cosine theta and a cosine theta. And then this is going to be a -1 and a +1. Cosine theta equals a -1/2, or cosine theta is equal to 1. Theta equals 2 pi over 3, 4 pi over 3. Cosine is -1 when theta is pi. So let's check my answers here and see what works. Let's check pi first because it's pretty easy. Sine of pi is 0. Cosine of pi is -1, and -1 is 1, not -1, so that doesn't work. Sine of 2 pi over 3 is going to be root 3 over 2. So that's going to be 3 halves minus cosine of that value is a negative 1/2 is 3 halves plus a 1/2 is 4 halves, which is 2. So that doesn't work. And let's try 4 pi over 3, which gives me a sine value of negative root 3 over 2. So this is a negative 3 halves. And it'll also have a negative cosine value of negative 1/2. So that's a negative 3 plus 1 over 2 is a negative 2 over 2 is a negative 1. This is my correct answer. This was pi over 4, 5 pi over 4, as was this. And this one was 4 pi over 3. Let's try this one. Sine theta equals a negative root 2 minus cosine theta. Again, I'm going to square both sides to get rid of that square root and to try and get my sine squareds and my cosine squareds together as a single thing to make a number. So this is going to be sine squared theta equals 2 plus 2 root 2 cosine theta plus cosine squared theta. And so I'm going to have, let's get everything in terms of cosine, that this is 1 minus cosine squared theta equals 2 plus 2 root 2 cosine theta plus cosine squared theta. It's going to make this 2 cosine squared theta. And that's going to make this plus 2 root 2 cosine theta plus 1. And that's not going to be factorable across the rationals. I would have to use my quadratic formula here, where a is equal to 2 and b is equal to root 8 and c is equal to 1. At this point, though, I don't want to get a square root inside of a square root. No, that's fine because it's going to be b squared minus 4ac, so I'll be okay. So cosine of theta equals negative 2 root 2 plus or minus the square root of 8 minus 4 AC, which is going to be an 8 all over 2A. So that's going to be 0. So this is going to be cosine theta equals negative root 2 over 2. And then that's going to happen. Cosine is going to be negative in quadrants 2 and 3. So that's going to be 3 pi over 4 or 5 pi over 4. Let's check my answers. So sine of 3 pi over 4 is root 2 over 2. Is that equal to a negative root 2 minus negative root 2 over 2? Change this to 2 over 2. So this is root 2 over 2. Is that negative root 2 over 2? It is not. So 3 pi over 4 does not work. Let's try 5 pi over 4. So the sine of 5 pi over 4 is a negative root 2 over 2 minus root 2. And the cosine there is also a negative root 2 over 2. Negative root 2 over 2. 2 root 2 over 2 plus root 2 over 2. It's going to be a negative root 2 over 2. That does work. So 5 pi over 4 is my answer. And now let's try this last one. Remember, I want to get sine and cosine on opposite sides when I'm doing this. Sine theta is -1 minus root 3 cosine theta. Square both sides. Make this 1 minus cosine squared. Bring everything over to the right-hand side. That's a 0. So I'm going to be able to pull out 2 cosine theta as a common factor and be left with 2 cosine theta plus root 3. So 2 cosine theta equals 0, or 2 cosine theta plus root 3 equals 0. Cosine theta equals 0, or 2 cosine theta equals negative root 3. Cosine theta equals negative root 3 over 2. Let's think about where my solutions would be. So cosine would be 0 at pi over 2 or 3 pi over 2. And then cosine would be negative root 3 over 2 at 5 pi over 6 or 7 pi over 6. Let's check my answers. So sine of pi over 2 is 1. Cosine of pi over 2 is 0. Is 1 equal to -1? It is not. Sine of 3 pi over 2 is -1. Cosine of 3 pi over 2 is 0. -1 is equal to -1, so 3 pi over 2 is one of my answers. Sine of 5 pi over 6 is going to be 1/2. Cosine of 5 pi over 6 is going to be a negative root 3 over 2. 1/2 minus 3/2 is a negative 2/2 or a -1. So 5 pi over 6 is also an answer. And sine of 7 pi over 6 is a -1/2. Cosine is a negative root 3 over 2, and -1/2 minus 3/2. That would be a -2 is not the same as a -1. So my only answers here are going to be 3 pi over 2 and 5 pi over 6. Let's write them in ascending order. 5 pi over 6, 3 pi over 2. There we go. And make sure that looks like a 5 before we're done here. There you go. very bad looking fives today. 5, 5, and 5. There we go. That's it for this section. We'll come back next time and talk about something else.